If you have European ancestry, your ancestry may reach directly back to the Ice Age world of Eurasia. It leads to a small group of people who lived along the banks of the Don River on the East European plain nearly 40,000 years ago. One of them, a man known to archaeologists as Kostenki 14, provides one of the oldest complete genetic windows into the ancestry of modern Europeans. Through him, we can reconstruct a story that begins in the cold plains and limestone valleys of the Ice Age plains, stretches south into the Caucasus Mountains, where modern humans and Neanderthals met, and continues forward through the glacial ages that followed. Kostenki 14 was buried in a shallow grave in a settlement overlooking the Middle Don River. His skeleton lay beneath a layer of volcanic ash from the Campanian eruption that took place around 39,000 years ago, which allows us to date him securely to between 38 and 36,000 years before the present. His genome shows that by this time, fully modern humans had already established themselves across Eurasia. The people of Kostenki carried the same genetic components later found in both Europeans and some Western Asians. They possessed a fraction of ancestry related to Siberian hunter-gatherers, another component derived from early European populations, and a smaller but important contribution from a very ancient lineage sometimes called Basal Eurasian. This means that even before the glaciers reached their maximum extent, the population from which modern Europeans arose was already a composite of several earlier branches of humankind. The mitochondrial DNA of Kostenki 14 belongs to the U2 lineage, which is still present today in small numbers among Europeans, South Asians and Central Asians. Mitochondrial DNA is inherited only from the mother, so this link provides a direct, unbroken chain from the women of the Upper Paleolithic to people living today. The U2 branch arose from the broader haplogroup U, which spread out from Persia around 60,000 years ago. By the time humans reached the Eurasian steppes, the U2 line had already diversified. One branch moved westward into Europe, another moved east and south toward Persia and India. Kostenki 14 and his relatives belong to the Western group. Their mitochondrial sequence represents one of the earliest surviving maternal lines in Europe. If your own mitochondrial genome belongs to U2, then your maternal ancestor was a woman who lived more than 43,000 years ago, most likely somewhere between the northern Caucasus and the eastern European plains. Her life would have been spent following migrating herds, building shelters from mammoth bone, and enduring the severe cold of the advancing ice sheets. Through her daughters, her mitochondrial pattern was carried across the millennia, surviving glacial winters and interglacial thaws. Some of her descendants remained in the west and became part of the early European populations. Others travelled south and east into Persia and the Indian subcontinent, where the same genetic signature persists today. The genome of Kostenki 14 also reveals a remarkable fact about the origins of his people. He possessed about 3% of his DNA from Neanderthals. However, the fragments of Neanderthal DNA within his genome are longer and less broken down than those in living humans, which shows that the mixture had taken place only a few thousand years before he lived. The region most consistent with this timing and geography is the Caucasus and Zagros, where Neanderthals had lived for tens of millennia in caves such as Mezmaiskaya and Shanidar, and where early modern humans were passing through as they expanded north from the Near East. Around 45 to 50,000 years ago, these two populations met and interbred. The descendants of that meeting carried their combined DNA north into the steppe and west into Europe. The Caucasus and Zagros acted as a natural bridge between continents. To the north lay the cold, open grasslands that stretched to the Arctic. To the south, milder valleys led toward the Levant. In this corridor, the ancestors of modern Europeans exchanged genes with the last Neanderthals. The mixture introduced genetic variants that affected the immune system, the skin and metabolism, some of which proved useful for surviving the harsh northern climates. Because Kostenki 14 lived so soon after this contact, his genome still carries long stretches of Neanderthal sequence that had not yet been broken apart by generations of recombination. The encounter that produced those segments probably occurred 2,000 or 3,000 years before his lifetime, meaning that his own grandparents or great-grandparents may have known people who still looked and behaved partly Neanderthal. The genome map of Kostenki-14 shows red bands scattered across all 22 chromosomes, marking regions inherited from Neanderthal ancestors. These long tracts, far longer than in any living human, demonstrate that interbreeding had taken place only a few thousand years before he lived, probably around 43,000 years ago in the Caucasus or Near East. When the genome is examined chromosome by chromosome, it reveals how deeply Neanderthal DNA had shaped his biology, from immunity and metabolism to skin, hair, and even behavior. On chromosome 1, these segments likely contained KRT family genes that regulate the formation of the outer skin and hair. Such variants improved cold weather adaptation by thickening the epidermis and preventing dehydration. On chromosome 2, Neanderthal fragments cluster near genes influencing lipid metabolism and insulin regulation. These helped convert stored fat into energy during long winters. Chromosome 3 contains Neanderthal-derived immune genes, including genes crucial for viral resistance. Chromosome 4's red tracts correspond to pathways that modulate inflammation, protecting against bacterial infection but sometimes increasing autoimmune risk. Chromosome 5 holds keratin and collagen genes contributing to skin durability. Chromosome 6 is dominated by Neanderthal DNA within a dense cluster of immune response genes that enhance defense against Eurasian pathogens. Kostenki-14's immune system, like that of later Europeans, was therefore a hybrid of modern human and Neanderthal adaptations. Chromosome 8 includes genes influencing hair and skin color, such as BNC2, one of the Neanderthal-derived alleles that contributed to lighter pigmentation in Europeans. Chromosome the 9th of May include variants affecting muscle and tendon robustness, consistent with Neanderthal strength traits that persisted in early Upper Paleolithic populations. Chromosome 14 carries segments near SLC24A5 and SLC45A2, both key to skin pigmentation, and these genes set the stage for evolution of lighter skin as sunlight diminished in Ice Age Europe. Chromosome 16 includes Neanderthal sequences linked to energy metabolism, influencing how carbohydrates and fats were processed. Across his entire genome, Kostenki-14's Neanderthal ancestry touched nearly every biological system. It strengthened his skin and hair, tuned his metabolism to glacial life, bolstered his immunity, and subtly influenced his neural and hormonal balance. These ancient red fragments show how deeply interwoven Neanderthal and human lineages had become, an inheritance still carried, though in shorter pieces, within almost every living person today. By comparing the genome of Kostenki-14 with hundreds of later individuals, scientists have traced how this early population evolved. The people of Kostenki form what researchers call the Kostenki cluster, the root of the later Gravettian and Vestonice populations that spread across Ice Age Europe. These groups were hunters of reindeer and horse, who made long blades of flint and carved beads from mammoth ivory. They built dwellings from bone and skin on the open steppe and buried their dead with ornaments and red ochre. Their genetic signature survived through the following millennia and reappears in later Upper Paleolithic Europeans, including blue eyes and light pigmentation. The U2 lineage therefore belongs to a population that endured the last glacial maximum, the coldest period of the last ice age, which lasted from about 25 to 19,000 years ago. When much of northern Europe became covered by ice, families descended from the Kostenki people retreated southward into refuges around the Black Sea, the Balkans, and the Caucasus. In these isolated havens they survived until the climate warmed again. After the glaciers began to melt, their descendants expanded northward and westward, giving rise to new cultures such as the Magdalenian and the Epigravettian. The same maternal line, U2, persisted within these groups, though in smaller numbers, while other branches of haplogroup U diversified further. The endurance of U2 across this immense span of time is extraordinary. It reappears in Mesolithic skeletons from the European plains and in later cultures that contributed to the Indo-European expansions. This persistence tells us that some families maintained an unbroken maternal continuity from the first modern humans of the Don River region through every upheaval of the Ice Age. Imagine the woman who first carried this lineage in the foothills of the Caucasus about 43,000 years ago. She belonged to a small band of hunters and gatherers that might have numbered only a few dozen individuals. Her people travelled between river valleys and limestone shelters, following the migration of herds. They made tools of flint and bone, used fire to keep out the cold, and perhaps decorated themselves with simple ornaments. Nearby lived other humans who were not quite the same, people with heavy brows and powerful limbs who we now call Neanderthals. The two groups met, exchanged words and gifts, and sometimes formed families together. When this woman bore her children, she passed to them mitochondria, carrying the U2 signature that she herself had inherited from her mother. Every daughter she had continued that transmission, creating a chain that stretches unbroken through 43 millennia to the present. Her descendants eventually spread in two directions. Some moved north and west into the Eastern European plains, where Kostenki 14 lived and died. Others turned south and east into Central and South Asia. Those who remained in Europe became the ancestors of the Gravettian hunters, and later of the Magdalenian and Mesolithic peoples who recolonized the continent after the glaciers retreated. Each of these cultures carried within them the same combination of modern human and Neanderthal ancestry that defined their Ice Age forebears. Modern people of European descent still possess about 2% of their genome from this early interbreeding. Every cell in the body carries small segments of DNA that originated from Neanderthals living in the Caucasus and the Near East. These ancient fragments influence skin and hair texture, immune responses, and even aspects of metabolism. When you sense that your skin resists the winter cold, when your immune system reacts quickly to a new pathogen, you're experiencing the lingering effect of genes first introduced by those prehistoric unions. The later history of these populations continued to shape the human world. As the climate warmed after the Ice Age, groups related to Kostenki 14 mixed with newcomers from the Balkans and the Near East, who carried the ancestry known as the Villabruna cluster. Together, they formed the Western hunter-gatherers of post-glacial Europe. These populations maintained the same level of Neanderthal ancestry seen in Kostenki 14, showing that the contribution of Neanderthals remained stable for tens of thousands of years. Kostenki 14 also links Europe with Asia. His genome shows that early West Eurasian populations once stretched from Central Europe to Siberia. The same metapopulation that produced him also produced the ancient Siberians, whose descendants contributed to both Europeans and Native Americans. Through this connection, the people of the Don Steppe are related not only to modern Europeans, but also distantly to the ancestors of Native Americans. Meanwhile, the small proportion of basal Eurasian ancestry in Kostenki's genome points to early contact with groups in the Near East, who would later give rise to the first agricultural societies. The Neanderthal fragments that remain in all of us are relics of that ancient encounter in the Caucasus corridor. Kostenki 14 still carried them as long, continuous stretches. In modern people, they have been broken into smaller pieces by 40,000 years of recombination. Yet they persist, scattered across our chromosomes, contributing to the traits that helped humans adapt to different climates. The continuity of these sequences proves that the interbreeding between Neanderthals and modern humans was not a brief or irrelevant episode. It shaped the entire genetic landscape of Eurasia and endures within every living descendant of those Ice Age peoples. To trace your ancestry back 43,000 years is therefore not an act of imagination, but a tangible reconstruction based on genetic evidence. If your mitochondrial lineage is U2, you descend through an unbroken maternal chain from the first successful Europeans. Even if your maternal line is different, if you are of Eurasian heritage, you still carry fragments of DNA from the same Neanderthal-modern human mixture that defined the Kostenki population. The pattern of your genome is a living archive of those early encounters. When we look at the life of Kostenki 14, we see not only an individual, but the beginning of a continuous European story. His people endured the advancing glaciers, adapted to new climates, and survived volcanic winters and long migrations. They were skilled hunters, capable artists, and resilient survivors. Through them, the human species learned how to live in the coldest environments on Earth. Their legacy is written in our blood and bones, in the faint sequences of mitochondrial DNA that link us to their world. Around 43,000 years ago, in the lands between the Black Sea and the Caspian, a group of modern humans and Neanderthals shared the same valleys and the same fires. From that mingling came the first ancestors who were truly European in the genetic sense. One of them carried the U2 lineage that survives today. Every time your heart beats, the energy that drives it comes from mitochondria, whose ancestry leads back to her. Her descendants endured the long ice age, crossed the glacial steppes, and saw the first thaw of spring across Europe. In every living person who bears traces of that lineage, the pulse of those ancient hunters still continues. Please click on these videos to learn more about our shared human history. Thank you for watching.